here and welcome to the session 1 of day 2 of this STTP on exploring immersive learning through augmented and virtual reality. It gives me immense pleasure to introduce you today's speaker, Dr. Ninad Dilip Mandare. He is an associate professor in the electronics department at KJ Somaya College of Engineering. He holds a postdoctoral degree from a Karlsruhe Institute of Technology in Germany and has a PhD in microfabrication and image processing from the Indian Institute of Technology, IIT Bombay. He has expertise in various fields such as sound signal processing, machine vision, embedded system, microfluidics and microfabrication, robotics, deep learning, and ARVR technology. He has won several awards, including a gold medal during his MTech at NMIMS University and also a Ratan Tata Scholarship for being the highest scoring student in MSBT diploma exams. Dr. Ninad is currently consulting several industries and institutions. He is also working on many projects related to autonomous systems and artificial intelligence based projects. He's also handling the spatial lab on augmented reality and virtual reality in KJ Somaya. So he has actually set up the entire lab in his college, like in KJ Somaya. So we welcome you, sir. And the sir is today going to brief you about all the hardware and software that is required to set up a ARVR. And also he'll be talking about the types of ARVR markerless and marker-based ARVR technologies. So we welcome on behalf of Father Conceição Rodrigues College of Engineering, I, Dr. Dipali Koshti, welcome you, sir, for this STTP. And thank you for accepting our invitation.
Thank you, ma'am.
So over to you, sir.
Yeah.
You can share your screen.
Yeah.
Yes, sir. You're audible. You can share your screen.
Yeah. Is my screen visible?
Yes, sir. It's visible. But PPT is not visible. Yes. Visible, sir.
Okay. So should we start now?
Yes, sir. Yeah.
So today I'm going to talk about different hardwares used in augmented and virtual reality, and obviously markerless and marker-based technologies also. So to start with, let me first introduce you to this diagram. You might have seen this diagram earlier also. So basically we start with the real world. Then we have augmented reality where you can see this donut is being inserted artificially into the real world. Then you have augmented virtuality where you are inserted into a virtual world and it's the world around you. It's completely 3D generated. And then you have a complete virtual world. So you start with real environment, then you go to the augmented environment where a part of the environment is now becoming a digitized world. Then augmented virtuality where your entire body is inserted into a virtual world, and then virtual environment where you just put a headset and you can see all the area around you in a graphical world. And mixed reality lies somewhere in between these two, where augmented reality and augmented virtuality are merged together. So what is the augmented reality? If you have used translators in your mobile phone, you might have seen this kind of thing where you show a image in some Russian language and it will translate it to English in real time. So augmented reality is a way of overlaying the computer generated content on a real world images. Basically, it's a game of overlaying the images. Now, how it overlays and all those technologies we are going to study, and there is no occlusion or content is overlapping smoothly with the real world contents. In virtual reality, you actually put on the headset so you don't see the real world anymore, and whatever this lady is seeing is shown on this display also. So she's seeing a virtual world completely where she can track her hands. So hand tracking is there through the camera, so she can see her hands, but she is in the virtual world. So This can be created by containing a 360-degree graphics. Typically, it is used for gamers, and synthetic contents are everywhere. Now, how much realistic those synthetic contents are will decide the quality of your virtual reality. Then augmented virtuality is where you put the real objects which can be projected and participate into the virtual world. So this is augmented reality where you can see this alien standing on a QR code in the real world. And augmented virtuality is where this you can see the other fellow from your eyes who is in the virtual world. So this kind of augmented virtuality is typically used in movie scenes, especially all those graphically advanced movies of superheroes or aliens, where augmented virtuality is must. Mixed reality is an overlay or synthetic content. So you need to have firstly a transparent glasses or a glasses with a camera and a display. Without that, mixed reality is not possible. And it uses both the synthetic and real world content together in equal amounts. So you will start seeing very less difference between real world, and that's where the mixed reality comes into the picture. So your all the graphics needs to be as good as your real world graphics with proper skins put onto the 3D models of each graphic world. And then you will start forgetting about your actual environment. So mixed reality is the future. We do have nowadays, we have heard of ChatGPT. The similar technology for image generation is being used widely, and that is called DALI by the same company that generated the ChatGPT. And that particular image generation can lead to something like diminishing reality, where you have your original image, where you have this opening of a gutter, and then there is a dustbin, and you can completely take out that part by filling all the details how it would have looked if these two things were not there, and this filling will result into this kind of output. This particular technology is called diminishing reality, where the objects are imagined which are not there and put in the background, and it looks realistic to the human, and that happens to a lot of training. So that is particularly computer generated images or GANs. Then the extended reality. So in extended reality, we refer to a real and virtual world. The X stands for replaceable world. So it could be VR, AR, XR, MR. So now we will start talking in terms of AR, VR, XR. So XR is like merger of this particular technologies together, and this X can be replaced by any of the letters that we have studied earlier. So you can imagine this particular glass with a overlaying display that can tell you where to rotate or also give you some information of how much time it will take to reach the destination. And this is really going to be a future in next 10 years. We are very close to it. I think this year only Meta has released this kind of glasses. Only 1,000 pieces are there in the world right now, but these glasses soon will be available for the public, and that is where we are going towards. So everyone will wear some kind of glasses instead of using mobile phone continuously. They will have a virtual world in front of their eyes with overlapping content on it. So to summarize, you have real world called RE, where you don't have anything digital in which you have direct view of reality. Then you have augmented reality, where virtual objects are overlaid into the real world. We have real objects projected into a controlled virtual world, that is augmented virtuality, so AV. And then finally virtual reality, where a complete immersion happens into the digital world itself. You don't have any real world content now. Now, what are the few sensors that you require if you want to set up your AR/VR glasses? So modern augmented reality glasses uses following sensors. First is digital camera, which is a must. And without cameras, none of this technology would have been possible. So camera is the first thing. We also call it optic sensors because these cameras are not only for the taking the pictures, they can also measure the depth. So any light related sensors, they are used for this. Next is accelerometer. So accelerometer gyroscope complete unit. It's called IMU, which also uses solid state compass and barometer. So with that, you get a continuous feedback from your hand. So whatever is your head moment, can be easily mapped into your virtual world, and that's why we need these sensors. So accelerometer is the motion or acceleration in XYZ direction. You also need a GPS. GPS is for the positioning of the person in the world. Now, if you are in the indoor environment, the GPS signal may not be available. What you can do is then you can just connect your GPS last known location, and feed it to your software. Gyroscopes is to give you the tilts, so all the XYZ tilts can be measured using gyroscopes. Solid state compass is used basically to point the north direction, and using that you can get the reference for all other sensors. And then RFIDs, how the RFIDs are used in ARVR world, we will talk about that later. But typically they need for identification and particular stage at which the particular projection should happen. So these are the different sensors which are typically used, and you will find most of these sensors already there in your mobile phone. So in fact, if you have a mobile phone, you do have a VR headset with you. You just need a lenses, which is typically 200 rupees lenses available in the market easily, and you have your own VR world. So this is how a VR headset look like, a virtual reality headset. Now it does have different functionalities, and based on that, the price of the current VR world may vary as low as 200 rupees to as high as I think 4 lakh rupees single VR headset. Artificial 3D or computer generated graphics are used in the VR world. So you need a lot of computing power if you want to run VR. And if you want a realistic VR, you need even lot of power. So this is how a simulated VR will look like. I will just play the video, and you can see this is a roller coaster ride of a simulated VR. Complete left and right eye projection. You can see there is a slight difference between the two, and this typically eye spacing, it's 6.5 to 7 centimeters between two eyes. So that much deviation is given between the two graphics, and you can see that very slight different locations this thing is ending with your roller coaster track. And this is how a real world VR will look like. So for that you need a 360-degree camera to record this thing, otherwise you will not get a full feed. So real world VR will look like this. And again, this could be a very high quality graphics generated VR, or it is the real recording that you do with 360-degree cameras available in the market. Currently, Insta VR is the 360-degree camera available in the market, which costs you just around 30,000 or something. And then there are Samsung 360 VRs available, which currently are discontinued from the production, but there are still some pieces available in the market. You can procure them, and soon there are many more companies going to go into the 360-degree fisheye lenses for the VR. Now in virtual reality, basically you wear the headset over the top, so this headband is very important to maintain the balance. Otherwise the entire load of this headset is typically on the nose. Now, different VR hardware, as I mentioned, 200 rupees Google Class Cardboard is there, which was released way back, almost 10 years now. Then you have your lenses. This particular thing is again a mobile phone slide into this particular lens. These are released by Samsung. Then you have Sony. They have released their PlayStation in VR mode, which was not a very big success. So they reverted from PS4 to PS5. They do have a support for VR still, but it did not replace the existing TV screens. So reason is typically people play PlayStation for more than 8 to 10 hours, and it is very difficult to wear the headset and play these 8 to 10 hour games. That is the reason it is holding back. Next is you have this with auditory feedback type of headphone released by Oculus, and then you have full room scale VR where you have RFID trackers and RFID mirrors put all over the headset and your remote, and it can track your motion in the room. So these are called room scale tracker, and they typically cost you in the price range of 1.5 to 2 lakhs. This Oculus type headset with auditory feedback has gone down up to 50,000. Sony PSVR typically 40,000 for the headset, and then you need to have console of roughly 40,000 more, so 80,000. This particular Galaxy Gear glasses are typically available in the market for 9,000 rupees, and Google glasses are available for 200 rupees. Some of the market leaders, when we talk about VR headset, HTC Vive is the best, though it is needing a computer for its computational power, and it has a room scale tracking, so we need a lot of space to utilize and get the best out of it. Then you have Oculus. Now, Oculus is purchased by a company called Facebook, and now it is named as Meta. So, Meta Quest 2 and Meta Quest 3 are the latest products by them, and Meta Quest 3 typically cost around, I guess, 60,000. And then you have Sony PlayStation VR, which is currently in production and still selling. Then a big hardware company named Apple got interested into this particular hardware, and they have released their Apple Vision Pro. They come in multiple sizes. So 256 GB Apple Vision Pro cost in India is around 3 lakh rupees, and 1 TB is around 4.5 lakh rupees. So you don't get them directly in India. They are imported from outside at these price ranges, and they are very useful for the developers, and it's a one-time experience one should always take. But again, it's a one-time experience that is a problem. So nobody wants to spend 4.5 lakh rupees for a device that they will not be using for a long time. And the main reason is fatigue. So you can go for a smaller cost. So this year, the latest headset release was MetaQuest 3S. I think it was released 1 month back, and its price is should be around 24 to 25. Currently, it is getting imported from outside. That's why the price is in the range of 40,000. But it should come down when it starts selling in India. Roughly 25,000 would be the headset cost, MetaQuest 3S, and it is the one of the most fantastic pieces of hardware at the cost to price ratio, similar quality to Apple Vision Pro, but cost is almost one fourth. And this is the current market leader or the king of the market. It is called MetaQuest 3 with 512 GB RAM, and it has every possibility of using it as a mixed reality, using it as a VR AR glass, and cost range is good. It has internal processor, so you don't need to buy a mobile phone. So that way, in a mobile phone price, this should be the best option one should go for. And these prices are very recent ones, so you can actually buy these devices at these prices. And if you are planning to set up a VR lab in your college, you should get 20 of these. Now, applications of VR. So, why this technology and why we all are here? So, it has many applications. First is industrial design. Then you have your automobile industry, which is working in VR, safety testing, healthcare, and tourism. So, these are the industries which are very much into the VR applications. Let us see one by one. So, one of the most popular application where VR has actually reached is the gaming. So, gaming with VR is a different experience altogether, and one should always uh, take the VR experience. Uh, then you have a military training. So military training is something where we don't expect our soldiers to be in trouble while they are getting trained. So military training is the one of the biggest applications of VR. Again, they don't disclose all this information, but VR is being used by Indian Army also, and even it started with majority in US, and they test the analysis of the each soldier whether they are fit enough to get recruited into the. Then in automation industry, if you want to showcase your designs, this is how a person will see like a design of a new car, and that can be used. Again, new designs are easy to visualize in 3D, especially in virtual reality, even than 3D. And it is basically a new way of looking the things. So, what we can achieve that you can't see on your 2D screen, we'll talk about that later. But this is where the virtual reality is going towards. Then medical is one of the most important applications. So imagine a doctor doing the operation, and if it sees the through its glasses, where is the point where you need to operate or any specific information. That is what we are working towards. And medical operations and all those critical points where it can see the ECG as well as at the same time overlaid heart. All these facilities are tremendously helpful for the doctors, and they will solve a lot of problems that we have currently. So this is where a doctor getting trained. So for that, both supervisor and a student needs to wear a VR headset. So they are seeing the same object but through different perspectives. So it can exactly see that this person is doing something dummy on this, but it has all those RFID trackers, because of which you can see the real images through their headset, and doctor can easily tell. So you don't have to cut open the head of a human to do this kind of brain surgery. You can do practice on the heads which are virtually there, and then you can operate with that. So you get the practice, and then you can do the real job. So it is like a simulation for your actual world. We do have applications of this VR in the gym industry. So medical fitness is a big problem. People don't like to go to the gym because of there is no attractive things there. So what you need to do is put your VR glasses and go to the gym and do the workout. And based on the situation or stimulus or EEG signal read from the user, this particular scene can be changed or shown to a user. And they are doing some machining in the gym, but they are seeing that they are doing their favorite work in the outdoors through the VR glasses. So gymming industry is one of the major industries where the VR will play do a breakthrough job. Next important application is the fear. So here you can see people do have a fear, height fear. So what this person has done is developed a plank, and there is a cat, and this lady is trying to save that cat. And through their VR world, they are seeing that they are standing on top of 100-floor building, and this is the base, and this is the cat they are trying to save. So if you see the things which are continuously there, your fear will go, and that is the logic that they use. So if you daily see height, your fear for height will reduce. So you can see through VR view, this person is standing on a glass, and there is a drop down, roughly a plane height at which he is standing. So that is how the VR helps in reducing the fear. Few people have the fear of ghost also, haunting ghosts. So we do have haunt VR 15150 kind of applications where they train people, and then at the end this lady shows up with their actual makeup and she's not real, and that way all the fear that you have about a ghost that can also be taken care of. Now, why now we are talking about this technology? What that has changed? So the original VR technology was launched in 1960s, but it took almost 60 years to reach to this point. So what are the things that are available which make this technology possible is firstly cooler graphics. So you have a better graphics card, and you are reaching where nothing in virtual world is like a cartoonish thing. You see very realistic graphics, faster processors. So processing speed has gone up like anything, following the Moore's law. So based on that, you can see the speed has reached almost a real-time lag. So what is the real-time lag? We will see that in later, but we should have minimum latency between the frames. Then lighter headset, the headset weight has gone down because of the minimization of the hard headset, and less lag time, which is a equivalence result of your faster processors. Now, coming to the investment in 2020, it has reached up to $4 billion market, and you can see the share of AR and MR was maximum in that. Second one is other VR consumer companies. Still, the VR enterprise level or VR hardware share is very less. Now, we talk about something called as VR benchmarks. So remember these benchmarks. If you are buying any headset, you should meet this benchmark. Firstly, battery life of that VR headset should be 6 hours and above. So if it is a battery based device, it should be a mobile VR and it should last for 6 hours. If it is tethered, it will have a longer battery life. Then flexibility of switching AR and VR. So you should have a pass-through mode. Now, what is pass-through mode is you take the images from the cameras attached on the VR headset outside and directly show it to the user on its screen. So that is what we call a pass-through VR. And you should able to switch between VR and pass-through VR. So AR and VR switching should be possible. That is the second thing. Next is vision. So MetaQuest 3 is currently lagging is in the 6 hours category because its battery is around 1 hour continuous reading. So we do need a larger battery pack, and for that you can use a simple power bank. Now there are power banks available in the market that are used to charge the laptops. They are called 65-watt power banks, and those can be easily connected to your VR headset, and typically that will increase your lifetime of your VR headset with mobility is around 6 hours. Then coming to the immersive field of view. So when you see through this, you will have a field of view. So typically your eyes see around 105 degree. So if you want a complete immersion, 136 degree is the benchmark, and retina pixel per retina resolution, that is the pixels in front of your eye, is roughly 2560 cross 1440. Now remember these numbers, these are very important numbers. This is per eye resolution. So if you are higher, that is good. If you have field of view around 183 degree, that is good. And all these benchmarks should be the baseline when you buy a headset or when you design a headset. Now, wearability, multi-hour or comfortable to wear, that is a very much requirement for this particular application. So if you wear it for 8 hours, 10 hours, you will start sweating, and this sweat should get absorbed properly, and it should be removable and washable. So that is another requirement. Next is room scale VR. So seamless potential position tracking should be there. So if you move your hand in VR world also, those hands should move. So that is what we call the room scale VR. And it should be inside out tracking, not outside out in tracking like HTC Vive. So outside in tracking means you have your sensors placed outside all over the room, and then you move inside that room. That is what we call the outside in tracking. And inside out tracking is something where you have all the cameras put to your headset itself, and that's how you can track the location around it, just like how your eyes work. Then you have load jitter. So if you move your head rapidly, the graphics should not jitter, and that is what we call a low jitter requirement. Affordability, ideally all the VR should be free, but VR HMD is the device, a model where the hardware cost is much more higher than the actual work, and then you earn through the software. So you make people go for the VR by giving them for free, and that is the only way you can make sure that VR is given to each and everyone, and then you start charging for the software. So that is how it should work. By cost wise, roughly 7 to 800 dollars, or 40 to 45,000 should be the price range for this particular VR headset. Usability, 120 FPS, that is the minimum requirement to have low latency and standard performance. It should not have any PC requirement, so it should be a mobile VR. So these are the benchmarks one should design for. And if you are buying a headset, these are the benchmark one should look for, whatever things that it does have and whatever things it does not have. Now, today's market is around 100 billion, and it will still grow. You will start seeing all the people wearing these headsets. Here you can see a room full of 4 people discussing on a project, and all 4 of them will see different angle for this particular house. So this is how the future will be, and this is how the VR headset will look like in future. Now, what are the different kind of experiences that you generally get in your VR world? First is wind. So wind is achieved through high-speed fans or blowers. So wind is one of the actuator that you put, If any of you have visited 4DX cinema, you might have experienced this wind. As per the movie, whenever there is a wind in the movie, you will get that wind out. Then you have rain sensor. So rain actuator and rain sensors are used. So rain actuator will spray the water. Then you have snow. So snow generator, those who have visited Snow World might know what artificial snow look like. So snow will be thrown out of this machine. You have flashing for the strobe effect. So flash is used. This typical flash exists for cameras for many years. Now they are used inside the theaters to give you the 4D effects. You have bubble generator for your smells. So what you need to do is put different scents, and then you rotate this thing and blow away the bubbles, and these bubbles will give you the perfume effect. So you do have direct perfume sprayers, which are basically a mist sprayer generated with piezoelectric. You do have flame sensors, which are risky, but you can have them to get the realistic virtual world environment. You have smoke generator, you have blowers, then you have leg sweeps, then you have back massagers and boosting effects, which are specifically created through the augmented holograms. For taking the input from the user hand fingers, these are the sensors available in the market. They take all the tracking of your fingers also into your VR world. Now, to interconnect everything into a system, this is how a VR cinema or VR world cinema will look like. Now, again, you will see that people started using this VR world cinema in many places in Mumbai also, and these are called 4DX movies. But what has happened is, out of all this, the fourth dimension was missing. So you get only the moving chairs and some blowers and maybe one or two sprays here between, but actual 4DX should have all these things. So you have water supply for spraying up the water, you have wind, you have fog, you have snow, you have bubbles, you have lighting, and then all this goes to a controller set which is connected to a 7D seat. Now these 7D seats typically cost you around 10 lakhs to 15 lakhs. So you can imagine a theater full of all these 70 seats would be a very costly affair. And then you have a very high speed computer controlling everything, and then you have sound amplifier and a 3D projector. So 3D projector is nothing but combination of two 2D projectors, but with a polarizing headset. So you need a polarizing glass, and 3D movies is currently the only thing, and high quality speaker is the only thing that we are getting into the theater, and that's why we are not enjoying the virtual world experience while watching the movies. Then, if you need to have a experience of spacecraft flying, these are the machines available. Now, typically these machines cost, range starts from 30 lakhs, and it can go up to 1 CR. And you have seen these kind of machines in many gaming arenas around Mumbai, and they generally charge ticket for each experience. And in when we talk with NASA and all, they use these machines for training their pilots. So flight VR is one of the example where you put your entire body onto the machine and you will get the experience of flying. So again, you have to have a VR world experience. You have other sensors around this chair. So parachute fall or flight or drifting or skiing, all these experience can be done through Fight VR. And these kind of VR headsets are available from China directly. So they are not built anywhere around the world. China is the sole manufacturer, and we do have contacts with them. So you can get this all this stuff from them directly imported into the India. A typical cost range, you can say, from 6 lakhs, as low as 6 lakhs, and it can go up to your wish 1 CR plus also. Then there are a few companies who are working on 360-degree treadmills. So when you move around, you should be feeling that motion, and that's where the 360-degree VR treadmill comes into the picture, where your body is completely attached to this circular ring, and then whenever you move, you are actually getting the feel that you are moving in VR world. Again, One 360-degree VR trade chair will cost you roughly around 36,000 lakh rupees. So it's still a very costly affair, and your regular treadmill will cost you around 14,000 rupees. So there is a lot of work to be done in this domain to get this cost down. And this is how the other version where you get this infidec, again 360-degree chair, treadmill, and you walk in this virtual world freely, and based on your walking it will change the experience. So again infidec will cost you 50 lakh plus. Then expression catcher. So you do get the headsets which you put onto your face, and your expressions are captured. Typically, these expression captures do come with full body suit. So you can see this lady wearing full body suit with all the trackers around, and then these trackers will convert her animated character. So most of the Hollywood movies and Bollywood movies are using this kind of tracking technology for their animated characters to get the realistic expression on the faces as well as to get the realistic moment. So this particular equipment is used by Marvel Studios, and they are tracking all the body movements with this infrared light trackers. And then you have facial expression camera capture attached to this, and then they act normally. So you do have Kinect, which is a low cost tracking device, and then you have your uh, thermal cameras available for finding out the weight and temperature effects. Then comes the cockpit. So typical cockpit trainings are done from 1976 onwards for pilots. So instead of giving them full flight directly, entire copy replica of the cockpit is made, and all these windows are filled with the LCDs of that shape. So people in the flight, they do not recognize that they are not actually flying the real flight but a simulator. And obviously these simulators are placed on a large hydraulic actuators to give you the flight experience. For the soldiers performance analysis, we do use a high-speed computer backpacks, and then there is a lot of wiring headset, and these guns are close to near weight, actual gun weight, and whatever moment you do with the guns, they are tracked down, and then we can note down the performance of individual. Now, in the sports also, player performance analysis are getting developed, and how you played is analyzed through these virtual gears. Then a teamwork effort is also shown here. So teamwork training is done by three soldiers, and they have these virtual bomb shooters, and then they work in team to get the desired results. So for that entire room, you can see this entire floor. This is made up of a moving room. So this entire floor shakes when they fire a bomb, and that's how the virtual world is created around it. So this is how the weapon will look like. Uh, Now, what will happen when you connect the weapon? These are the virtual weapons. So you have a USB charging port over here. You can see that, and weight is exactly to the real world gun. And then you have dummy cartridges which get over after 6 shots, and you have to recharge the cartridge. So everything is made as close to the real equipment. In fact, we many times use the actual guns and modify them to act as a VR gun. And this is how the entire room is placed on a hydraulic actuators. So you can see that it can move the entire cabin in which the people are there. And to track down their movement, we do use depth camera. So Percy is one of the easiest to get depth camera, which directly gives you depth estimation, and you don't have to do a lot of things to get your depth output out of it. So you can track down the motion using Orbax Percy cameras. They typically charge you around 30,000 rupees. Then you have your Xbox Connect. Again, this technology was not taking up, so Microsoft lost it, and then they moved to your regular consoles. But these Xbox Connect were built for gaming, and people started using them like anything because they were not requiring a human to wear any specialized thing. So These Xbox Kinects are still available in market, but they are before the production ended. So you will have a raise cost. Typically, they cost you around 36,000 onwards, and now 55,000 is the current range at which you get these Xbox Kinect. So now we move from virtual reality to augmented reality. Firstly, let us see what is the difference between the two. So augmented reality overlays the 3D generated content into the real world, where virtual reality, you put virtual world around your eyes. Second is you will able to interact with the real world and virtual world both, where since you are completely in virtual reality, you are completely in virtual world, your real world connections are gone. So there are chances that you wear a headset and hit a wall because you actually become blind in virtual world, real world, sorry. Then there are many chances while playing in virtual world you get carried away and hit your hand onto the wall or somebody, or even there is a chance of damaging the joystick. Secondly, is there is a clear distinguish between both worlds. So still now we do not see any augmented reality which is so good enough that you cannot make it, whether it's a real object or not. But people are working towards it. Here, virtual reality again also it does not have a realistic graphics, so you can still differentiate between real and virtual world. Now, augmented reality is achievable by your smartphones, and that's why it is the easiest technology. One can go for buying just a tablet or AR wearables, and they are there in your augmented reality. VR world again, Google Cardboard is one solution, but they are typically achieved through VR headsets. So, augmented reality technology that superimposes the digital informations on the user's view. So what are the things? It blends real and virtual world in real environment. It is still interactive in the real world environment and lot of 3D modeling. So 3D modeling is one of the core behind the augmented reality. And again, those 3D models should have lighting effects, should have skin so that it looks realistic object. So these are the things which makes your augmented object look apart from your real world objects. So, what are the benefits of using augmented reality? First is competitive advantage because it's already available in the phone, so it is way ahead of your virtual technology. Virtual try-ons. So when you go to the mall, if you like one shirt, then virtual try-on can allow you to see how that shirt looks on you. For that, you just have to stand in front of mirror, and through your camera, you can see that particular virtual try-on shirt onto you. Then unique customer experience because of this virtual try-ons or all those augmented world experiences. It is something very new. And then obviously you might have came across Amazon, and in Amazon app you do have this particular section where you can place the object into a room and see how it will look like after that object arrives. So you get a lot of scope in the marketing when you touch the AR. Typical AR application building process. Here you will see that first you need to choose your AR application that you want to build and launch. So idea should be there. You have to write down all its features on the paper. Then you have to choose a tech stack or create a deployment strategy. Then you can hire a AR developer. Now here, these are nothing but mobile developers. So any Android developer can become a AR developer, and then test the app and launch the product. So this is the typical workflow that we follow for generating a AR app inside a company. And this is how it looked like. So this particular design, you can see it is a building just kept on a table, and then you can see all the virtual roads are built around that building. Also the structure of the building looks different than the original one. So that is how it should look like. Next is AR used in medicine. So it is very difficult for medical students to imagine everything because it is not possible to bring the live organs open. So what they do is they do build 3D models of this and then let the blood flow through it so that you can actually see the object. So in medicine, it is very important that you can see the body part through the your AR world. So this is how it will look like. and you can see there is a live annotation of the each and every body part on top of uh, the image that we are seeing. Now, different types of AR. Again, there are 6 major types of AR. First is marker-based AR. So here, person uses a marker or an image that triggers the display and gives you the digital information. Second is markerless AR, in which the AR uses devices, camera or GPS location. So there is nothing like a marker in front of the camera. You directly uses the information that is coming from the camera. Next is projection based AR. Now, typically people don't talk about it, but it is one of the most important AR areas. So I will show you some examples. Then superimposition based AR. So here you overlaid a digital information, just like in earlier case where I showed you that the annotation was done for the parts which are not actually there. Then you have location based AR. So maps, Google Maps, or I think Google Maps has already activated this location based AR. So you can open your maps in real time and see where to go, and it will scan the image and find out which objects are there. And then finally comes the mixed reality, where you combine your AR with the virtual and real world. So we'll start with the first part of the AR, which is a marker based and markerless AR. So here you can see there is a book on which the tractor is standing in 3D and rain is happening over it. And then you can see this Amazon type application where you can place the sofa and you can see how it will look like into your room. So marker based augmented reality. So you might have visited Starbucks. So once you go to the Starbucks, you can show it to your glass, and there is a marker located inside the lid of your Starbucks cup, and that will suggest you the drink that you can get for this particular type of cup. So marker based augmented reality that uses marker image or a trigger points. These markers are typically known as targets, and they are 2D images or a QR codes. So many of you have already used QR. So I think most of your UPI payments are happening through QR. So these 2D images are nothing but marker based. So your UPI code QR can be a marker. Now these points not only allow you to place the object in the 3D world, it will also take the orientation of the marker and copy the 3D world object or 3D object in that particular orientation. So this is one example where this house is being placed on the simple marker, which is a rectangle and a triangle. So this is the simplest marker that you can draw. This is the another example where you can see this person is wearing a Apple Watch, but actually there is a marker. So typically AR markers look like this. These are put in museum exhibits, product, gaming, and these are for the information. So this is how a typical QR looks like. It should have 3 concentric rectangles, and then you have a specific pattern to recognize this orientation of the QR code itself. Then you have your markerless object like this Pokemon Go. This is a very famous game, and people playing this like crazy. So this was the first game that triggered the AR world, that showed the power of your mobile phone camera and integrated with the app, where you have to capture this running Pokemons and by throwing a ball at it, and then at different GPS locations, different Pokemons will show up, and people have to run around the city to get Pokemons that they want. And again, what you can see is it is a good physical exercise, but people got involved, and 1 or 2 suicide cases also happened. Not because of this app, but there was another similar app. So this Pokemon is a best example for markerless augmented reality. So marker based we have seen where you have this kind of QR codes, but markerless where you have the objects directly placed onto the surface. So here lot of computation is required for markerless augmentation. We do need a camera and a GPS location. Firstly, if there is no marker, we need lot of other things to get this information from, and they are predetermined markers. Typically, we need a pre-trained model to put the image into the real world. So these pre-trained models are generated through training the deep neural network. Typically you give lot of images of that area, and then you mark each and everything, and then you run the markerless augmented reality. So this is good for a societal or a closed premises where everything is known to the user, and all the movements can be tracked down. Markerless AR can be used in a variety of settings such as navigation, which I mentioned. Google is working on it. Then there is a tourism and gaming industry. So location based AR or position based AR, that is what we call this markerless ARs. So this is one example. So I think it is released now, Google Maps AR, where this dog kind of person will show you this dog actually shows you the route, and then this you have to follow this dog. So if you have Google Maps, just see Google Maps AR where they're working with you, and it is very easy to get around the directions, but works only in outdoors. So indoor navigation is still not possible with Google Maps AR. It will be made possible soon, but it will take around 3 years more. Then you already have seen this. If you have Amazon app, you can open, look for a sofa or a chair, and then you can place that sofa or chair in your room virtually. There are many kids applications where they see a lot of animals being placed onto your room. So this is how it places. It actually generates a grid, three grids, for two for the walls and one for the base. And based on that, it finds the vertex and then it places the objects. So obviously, once you start the camera, it will take some time to place your object into the world, and then you can move it around. It will automatically scale also. So internally, this is how it computes. It computes the position and the location. It looks for this particular age, and obviously, if you are pointing it towards a top of your room, you can place this sofa on top of your room also. There's no gravity effect because it's virtually placed. So that way, you can fool the system by showing it wrong locations. But typically, it is well trained and it can determine the floor. So floor detection algorithm is one of the crucial aspects for using a markerless AR, which was made possible through image processing only and lot of training data. Next comes is the projection based augmented reality. So what is a projection based augmented reality? If you see, this is the example of projection based augmented reality, and you can see only issue is the shadows. So when you put projections, and if you put your hands on it, you can see the hands are getting projected, and in real sense the height is represented by the color. So blue is the lower region and red is the higher region, and they are just projected on top of these mountains. Then you have another example where a dial pad came out of the ring, and then this projection can be used to dial a call. And this is again an example of projection based reality. So if you see, they can be used in variety of settings. One is museum, trade shows, architectural designs, and they will add to the user experience. So this is the shoes where you can change the design of the shoes. If you see a raw shoe, it is just a white shoes, but you can put different colors. This shoes was developed by Adidas, and it was demonstrated. All their models or colors can be projected, and it's a 360-degree projection. So this thing rotates, and you still manages to project. So you can see here this particular region is just a projection and there is no such strap on it. Even the laces are projections, and you can see how perfectly it is fitting the edges. Another example, this lady is being operated. So the tumor was projected inside her brain, and this is the hair removed, and you can see it becomes easier for us to uh, do the projection and then do the operation. So for doctor, it becomes very easier to use this projection and operate. This tumor image was gathered through the what you can say MRI scan of that lady. Now, to get the right depth estimation, you need a depth camera. So you have your RGB model in the depth camera, you have right and left imager, and then you have IR. So it also has a night vision mode also. And projection based ARs works best when it is connected to a depth camera. So depth camera typically is by RealSense or Microsoft HoloLens to detect the surfaces and how they are casted. Next comes superimposition based AR. So superimposition is where you put your digital information in top of the real world. Now these can be achieved through smartphones or head mounted devices, also known as HMDs. These are smart glasses, practical try-ons, and all these things can be done through the superimposition. A simple example is you have a broken architectural structure, and then you superimpose your building, so how it would have looked if it was not broken. So in India, many of the castles are broken like this, and one can try out superimposing them. Lot of scope in architectural domain. Then repair is another place where this superimposition is useful. You can see this person is actually using XM reality glasses and seeing that which pin might have a problem. You can see there is no hand. This hand was inserted, and this pin needs to be plugged out, was inserted from outside. So you just have to point your camera to the hardware. It will recognize all the edges, do all edge detection, and it will find out which is the problematic wire and compare it with the standard diagram, and then it will replace it. You can also do a superimposition for getting the information about the medical thing. So this is, you can see the bones are being superimposed on the hand, and it might happen that they do not superimpose perfectly. So here you can see one of the edge is coming out, and that is not perfectly superimposed. But there are chances that you get much more information about the radius of that bone and all those information, and then you give a precise cut after doing a superimposition. Now, next is GPS based tracking. So, AR basically utilizes GPS. It also utilizes contextual information. And when we upload any photo on Instagram or WhatsApp, people do write comments about that photo. And with that photo, its GPS coordinate is also linked. So, what will happen once you upload this photo on the website? It will start gathering that information, and based on this information, nearby building landmarks, everything is pointed. It will also get the real-time updates. Outdoor and indoor scenarios are considered, such as Wi-Fi, Bluetooth, ultrasound beacons. Navigation and tourism is industry where this navigation, GPS based navigation, AR is useful. And again, gaming industry, one of the examples is Pokemon. So this is how it will look like. You just take out the camera and point it to a certain street, and it will start showing you the restaurants, the ATMs, the hotels, the grocery store, parking where it is available. That is how the superimposition GPS based tracking works. And it has to be outdoor scenario. So you cannot do this in-house. So inside a building, you don't get three satellites. Typically, 7 to 21 satellites are captured to get the perfect GPS, but three satellites people say are good enough. Then you get this kind of information where while you are driving, your car windshield is overlaid with the LCDs, and you can say after 100 meter take left, and then there is a map, or you can see Starbucks is here, McDonald's is here, parking is there, people are walking towards the car. So this kind of information is given through the vehicle, and typically autonomous systems or autonomous vehicle use this information. Now, coming back to five major types. One is marker based AR, second is projection based AR, third is location based AR, Next is overlay, where you put the information on top of it. And last one is contour based, where you place the object in the virtual world by finding out three walls or two walls and a flooring. So this is how a overlaid information is there. So you have your rendered data with all the locations, and then you have your video image, that is a frame, and finally you merge both of them and you get the final registered overlaid image. In movies you might have seen this kind of shots, but it is not very far away. In fact, it is easily possible to achieve this kind of information overlay onto your phone, and this is through the Uber drive. So that is how it calculates, and it's the future. Maybe after 10 years you'll start seeing it in some of the countries, and maybe after 30 years you will see it in India also. So benefits of using augmented technologies, it enhances the education for training purpose. So like I am doing this virtually through a video call, the AR will be even better. You will see my avatar standing there and providing this lecture. So more interactive, more immersive experience you get. Then it increases the accessibility. So digital information format is there, whatever overlaid information. So you don't have to buy hard the things. You can just show it to your camera. Google Lens is the best example. So if you don't know anything, open a Google Lens app, take a picture, and it will tell you everything about that particular object. Cost effectiveness, since you already have mobile and internet, it is really a cost effective to train the workers. And you have seen this example where person was repairing a certain device by just looking at the camera. Enhancing marketing, so once you have 3D view, when we construct a building, they make a sample flat ready first, and then people have a look around that sample flat and then they buy the house. So in a new construction, imagine that entire sample flat is just a temporary flat built only to sell the other flats. So that is no more required if you have a AR try on. So you can just look at through the phone, and you can also then make multiple sample flats for the same building without spending a penny. So all your sample flat cost, interior is saved. So that's how you can save it for marketing and advertisement. Enhancing user experience. So once you have digital information overlaid, obviously you'll get a context, and that's where you will get more information. So jo abhi, when you go to the tourist place, there are people that run around you called guide, that you can just avoid by using the AR. Improving my productivity. So obviously in real time you can get the guidance from the expert, and it will obviously increase the productivity and efficiency of the worker. Enhancing communication skills, since you can see in one of the images I have shown Russian to English. So it is easier for you to move around in the world having this AR technology. And improving the safety, because you are giving a real-time feedback from your workers. Safety hazardous environments, you can actually save a lot of lives. Now, how you can build this app for free? The first way is to get the AR development platforms. There are AR Core and AR Kit, which are the most popular free development platforms available for Android Studio and Flutter. Then AR development softwares are there, such as Vuforia or AR Toolkit, which are free softwares. Then free 3D modeling softwares such as Blender, SketchUp are there. Then for app creator, you can use AR Studio directly to create the apps, or Android Studio is also there. And finally, you can use free AR SDKs such as Easy AR SDK and so on. Now, what are the 3D systems that we used in AR? Firstly, 3D systems for augmented reality needs 3D models. So first thing you need to convert is real world objects through its corresponding 3D model. So typical 3D scanner will cost you around 70,000. Nowadays it is in a range of 45K also. There is a company called Creality that gives you this 3D modeling camera. Then 3D trackers are there that to track the moment. IMU sensor will typically cost you around 1000 rupees. And there are some sensors which are available at 300 rupees also. So once you have these 3D models ready, you can see there are 6 mobiles placing different objects in the same room. and physically there none of the object exists. So you can see how the 3D model is there. So 3D model overlays the digital information into the user's view in the real world and with their orientation. You need a files like OBJ, FBX to get these models in running on your AR app, and you generally make them on Blender, SketchUp, or Maya. You can see a full human body with skin taken apart, how it will look like with the muscles that is projected over here. The 3D models can be used for visualization, gaming, education, training. They also have information about head mounted devices orientation. So definitely 3D models are required. Here you can see a lady standing in a room, and that particular lady can be changed into different objects. These are the three objects available to choose from. So 3D representation is basically real world objects into overlaid into a digital world, or informing information is overlaid onto the real objects, and that is how 3D modeling softwares are useful in AR. So if you start with AR, first thing is all the ARVR applications are typically built in C sharp. So you should learn C sharp software from app called Solo Learn. It is very user friendly app, and then you can start building some 3D designs onto a software called AutoCAD, which is the free software for students. 6 months free access you get for every release. So it's actually free software only. Next is you start building your simple applications. Like here you can see QR codes being placed all around the room, and you are just asked to build a projection properly oriented onto this QRs. So 3D systems, 3D modeling, 3D animation. So 3D animation, I refer using Maya, but I have worked a lot with 3D Max Studio. So if you know Autodesk or AutoCAD, then you should always go for 3D Max Studio. Cinema 4D is one more software which typically Hollywood movie directors use. 3D scanning systems, as I mentioned, there are stereo cameras available, and you just rotate the object in front of a 3D camera and it will make a 3D scan out of it. Then 3D rendering engines, Unity and Unreal are the best engines available, and you get plugin like Euphoria for them. Both engines are free, so most of our AR/VR app development is done through Unity or Unreal. Backend coding we generally do in Python, and C Sharp is another option. Uh, AR development softwares, AR Core and AR Kit, and Vuforia. These three names you should remember. All these three are free, and you can use them with your Android Studio to make an Android app, or it can be also used with Apple app development platforms like Flutter. Then AR head-mounted displays. HMD should have camera. So Microsoft HoloLens, Epson Moverio, Google Glass are the three examples. I think HoloLens will cost you in the range of 4 lakhs, including taxes, 4.5. Epson Moverio is around 1 lakh rupee, and BT4 is the model you should look for. Google Glass, I have already said that 200 rupees cardboard is good enough to make a Google Glass. So these are the HMDs which are AR compatible. Now VR, AR, Google Glass, there is no difference. You just have to keep your camera open. That's it. Then your Google Glass will become a AR glass also. Now, this is a specific example where robotic arm is being made, a 3D projection that fellow can see through the depth camera, and then AR controller will allow him to control the 3D printing of the arm. So it is very important to build such kind of applications in industry so that people will get a full power of AR, and designer has to work hard towards it. A lot of hardware is there. People, when we talk about AR/VR, they just think it's a game development platform, so you have to sit on Unity and do some animation, and that's all you have in your AR/VR. But practically it is way different. It needs lot of hardware, lot of experience with sensor integrations, actuator integrations, and a computer, portable computer, mobile app development. So it's a blend of hardware, software technology with all mechanical designs. Now, superimposition based AR is often used in a field where we see overlay based or on the top ARs. So coming to the diagram again, what we started with reality. So you have completely real physical world. You have virtual reality on the other hand, where you are completely into synthetic or digital world. Now you do have augmented reality, augmented virtuality. So I guess the difference is clear. And now we shift our talk to last part of this talk is on mixed reality. So it's the combination of the both worlds, or what you can say, best of both worlds. Experience from both worlds can be merged. So now we move to the last part of the talk, mixed reality. So exploring the convergence of physical and digital world, that is the promise given by a mixed reality. By the convergence, we do mean people will able to enjoy and others will also enjoy along with that. So how we can merge both of them? So typically head mounted device, you need to make it transparent. That is the first requirement to have a for the mixed reality. So don't go through the screen like camera and screen, what we have in Apple Vision. That is not the correct way for going for a mixed reality. The true lens or true mixed reality HMD will be Microsoft HoloLens compared to its Apple counterpart. Now this is a video. I think no, that this is a bird from Microsoft HoloLens, and this is how it actually looks like. Those who want to experience, I have this in my office, so you can visit Somaya any day, and I will show it to you how it will look like. So this actually you can see the holograms when you can see an entire galaxy through your HoloLens. So this is how you wear a HoloLens and show it the world around you. Now, first ever mixed reality headset was built already way back in 1990s, which was developed by US Air Force. And in 1994, they have also opened it for the public for mixed reality virtual displays, and they call it virtual continuum. Now, you can imagine this kind of virtual try-ons. As I already mentioned, these two people both are wearing the mixed reality headset, HoloLens, and then they can interact and other person can see. So this entire thing or entire audio showcase of Bose headphones is not there. Physically, they are not there, but both can see it and they can do some operations on it. So that is how a virtual reality HoloLens to HoloLens communication happen. One more important thing to note is HoloLens is a full-fledged computer. So back of this headset is a full-fledged computer, and that is just a display and some battery in front. So that is how the weight balancing has been achieved. So through a mixed reality spectrum, you have your physical world and digital world completely merged into together with a mixed reality. You have your human computer and environment. So if you have human computer interaction, it is called HCI. Then you have human environment, it is conventional reality, and then computer environment is the perception. So combination of all these three makes a mixed reality. So physical world projection, augmented reality, virtual world projection, virtual reality, and this is where the mixed reality spectrum lies. Two brand new devices already available is Microsoft HoloLens and Samsung ADC, HMD ODC. So these are the devices which you can buy from the market. They have full 6 degree of freedom and you can see through them. And you will get the opaque display with Samsung HMD ODC. You get see-through displays through Microsoft HoloLens. Now, coming to the virtual reality, we know that traditional virtual reality needs a mobile phone. So that is, or a display in front of the eyes. And on the other hand, you don't have display in front of the eyes in augmented reality. So augmented reality has a larger scope because there is nothing mount to your head. So there is no problem of you getting sweated. And that why the quality of the AR, if you build a quality AR, it will start selling soon because no extra hardware, your mobile phone and app development. So to get into the AR/VR world, developing an AR application is the simplest way to start it. Now, if you see the difference between the three, virtual reality, need to get started with 3D designing. For augmented reality, you need to start with what you can say app development. For mixed reality, you can start with Microsoft SDK. So Microsoft HoloLens SDK is the free software which you can start with. Then you have full immersion in VR. You have real world plus some digital objects, whereas you have interactive real world and interactive digital objects in mixed reality. So mixed reality and AR are very much the same, but here you need a mobile phone, whereas in mixed reality you need a glasses in front of your eyes. So augmented reality can be easily achieved through HoloLens, and virtual reality can be easily achieved through this Samsung device, and mixed reality can be achieved through both, because this particular thing has a camera, so it can go into the pass-through mode. So what you see is real and virtual worlds are intertwined in the mixed reality. In virtual reality, it's not making sense. So after 2 3 hours, you need to come out of the virtual reality. In fact, we were trying few patients, mental patients, and we sent them to a virtual world and show them their past memory. It had shown a tremendous effect, especially improving their behavior, social behavior, and it can be used in wise way also. It can make a good thinking human mad through virtual reality. So it is very risky also. At the same time, it is very useful also. On the other hand, augmented reality, it has already came into the picture, and virtual reality and mixed reality is something which we would look for. So what are the major advantage with mixed reality? You have overwhelming HMD cameras, effective communication, detailed view, and good experience. Now, typical algorithms used in MR are object recognition, object tracking, image registration, image mapping, visualization, rendering, simulations, and information transfer. So if you see, it is a sub branch of your computer graphics and image processing courses. So these are the two mandatory courses one should have before developing any MR application. So you need a calibration, virtual rendering, object recognition, registration and mapping, modeling of the space, then object tracking, and then finally information transfer. Typical architecture of mixed reality is you have mixed reality content, you have server, you have network, finally you have client, and then the rendering. Now, this table summarizes all the softwares that you have. Particularly, you start with AR Toolkit, 2D objects, and platform supported Android. C Sharp is the language you should look for. Free and open source and supported by AR Toolkit. Layers, again, 2D objects, Android and BlackBerry supported. HTTP or REST. Then it's a paid software, and layer 7 is the current version. You have Euphoria, Zapbox, EasyAR, Kudan, Wikitude, ARKit, OSVR. Now Meta 3 SDK is also released. So Meta 3 SDK and Windows Mixed Reality, which is a mixed reality version of your Windows. Now, what are the problems currently? You should have high cost. So basically, all the mixed reality glasses doesn't come below lakh. The environment is not trained, and that's real environment. So again, that is a disadvantage. You can't touch in the real life objects being projected in front of it. Then you don't get that feel back. So you need a haptic glove or something to get that feeling back. And finally, communication will be public, so should not be shared in the group. So mixed reality glasses do interact with each other, and one can see what other is doing. So kind of privacy threat is there. Now inside your glass, this is how it is made. As I mentioned, this is a open view of your Microsoft HoloLens. So you have this back screw to tighten the headset to your head. You have this entire strap around. This is a head comforting device. Then you have a depth camera in front. You have two more cameras, side cameras. Then you have accelerometer, gyroscope. These are the LCD lenses that you have in front of your eyes. These are the projector, tiny microwave transmitter receiver are there. This is the acrylic glass in front. Then this is the processor. Graphic processors are put in. This is the battery. Then you have this cushioning blocks over here and some attachment. Then you have speakers at the bottom. You have your main processor chip, and then there is a RAM and hard disk at the back. Once you assemble, this is how the Microsoft HoloLens will look like from the top. And these holes are created for heat sink as well as to take out the sound from the back. This is the power button, and this is the knob you will see to tighten or loosen the head strap. So mixed reality will increase the productivity. Obviously, once you wear a 4 lakh rupee headset, you have to be a productive person. Next is in the real time e-commerce, you can visualize the things that are not there, and it will definitely help you sell these products easily. क्योंकि जो दिखता है वही बिकता है. Immersive learning training is one of the major thing that we do. Now again, when I interacted with ONGC, they need people who can go under sea and experience it beforehand, so that when they actually go into the sea, there are a lot of problems. People faint, vomit. So this kind of things, training industry is looking for people in ARVR. Games already I mentioned. Again, medicine. So you can see all the applications of ARVR are the applications of your MR also. So like here, this lady is trying to get it repaired with the help of her supervisor using Microsoft HoloLens. One of the industrial project that I built, this is what we call a digital twin. So again, you need a lot of IoT sensors. So you have those IoT sensor input in front of you in the virtual world. So for that, we used a kiloscum per pump, half watt or something like that. Then we built this kind of arrangement where all the sensors were put on top, and then there are level sensors and measuring knobs. Then all the pressure sensors and all the tubes interconnected were digitally mapped. We do work with Mavia, which is a European partner company. These people have a complete tracking head helmet, and this is a tractor training platform. So Mavia has asked us to build this particular thing, digital twin for your JCB, and it needs a lot of information like mechanical strength, the weight it can vary, where it is currently, physical position. We do have armchair version for this, where the entire screen is attached to the chair itself, and then you can put different controllers. So this is where it is trying to lift the tree. If it lifts a heavy tree, the entire thing should flip. So armchair version is not the best suited version. So what we propose to them is to use a depth camera, a motion chair, a gyroscope, a very high speed computing facility, uh, this particular board, which we called SBC, single board computation. And this particular board is Latte Panda. And then you have a GPU for all the training, and then you have a screen. For the hardware, moving chair hardware, we contacted Fun VR in China. They have provided us this platform. This is a hydraulic one. We got an electric one for rupees 6 lakhs. Then there is a finger coaster somewhere in, I think, Churchgate side. This particular system was there available in the market. So they are using digital, all these PLC systems are there and easily controllable. And they just move the servos. Then we got the JCB cabin, which costed us around 8 lakh, and mounted it on 3D platform. And then we also worked with the lift trainers. So these lift trainers is one of the rare people. You see all the tall buildings, On top of it, there is one lift operator. So this lift operator is paid 1 lakh rupees for 2 hours. So that is a heavily paid job. The reason is it's very risky business. This entire lift is already at 1,000 feet or something, and then people have to lift 2 tons, 3 tons metal bars on top. So people do need a license for it, and getting a license for this is also costly. I think one pilot license for crane in Mumbai will cost you around 1 lakh rupees. But it's kind of investment, so it is like a pilot like job. And there is no shortage. In fact, there is a shortage of pilots. So if somebody wants to look for a high earning job, one should go for driving the cranes. So for that, we made a simulator, crane simulator, and this is how the final setup would look like. Again, it's a mini JCB cabin, so it came with actual JCB machinery, which is connected to IoT and made a digital twin out of it. And our partners in Europe worked on a VR cave system where they put LCDs, and whatever information that we are getting from it, they were feeding it directly to the screen, and you can see that this is how we made the virtual world out of it. This entire VR cave is fully made up of LCDs from all the sides. So once you go out of into the cabin, you don't feel like this is not the actual cabin because of all the views that you get from the cabin. And physically, this is how it will look like if it was not a complete LCD, but you need to wear a headset. So this is the thing that we avoided, and that is how it was built. So you do get these kind of platforms, and if you want to start with ARVR hardware, I highly recommend get one of these platforms and start working with simple movies, converting your 2D movies, old Bollywood movies into 3D movies. Typically, RTX 4080 is the current hardware that you should go for. Intel i 9900K, but now I think it is 13900K. So 13th or 14th series is going on. So Intel i9 14900K. Then simple Corsair RAM kit with DDR5 you should go for, and Samsung EVO M5, I think M2.5 is the latest hard disk you should look for. So that is the hardware requirement, and obviously you should have RTX. I think 4090 Ti is the card. You can go for Latte Panda, which is still one of the good quality SBCs, or you can go for Intel NUC i7 kit. So with that, I will end the talk, and if you have any doubts, I would be happy to answer them.
Yeah, thank you, sir.